the previous lecture we had seen the concepts which are related to the moment when it is used in the problem. In the equilibrium we have also said that along with sigma fx and sigma fy we are required to consider the equation for sigma moment also. Now moment, when we talk of the body which is in equilibrium, we will be taking the moment at any point of that body, and preferably it will be the point through which several forces are passing. Now when several forces are passing through a single point, and if we take moment about that point, then all these forces will result in moment equal to 0, and the equation will be simpler. If we choose any point on that particular body and if we take the moment, then all these forces will be the ones which are active for producing the moment, and you will have to find out the perpendicular distance of each of these force, or you are required to resolve each of these force in the horizontal and vertical direction and then take the moment. So keeping this in mind, we will proceed with the next set of problems. See the first problem which is given to us. Now in this first problem there is a beam which is given to us, which is A, B, C, D, E, and on that particular beam there are three loads, namely 7.5 kilonewtons, 10 kilonewtons as well as Q kilonewtons. This beam is supported by two cables which are attached at point B and point D. Now when we consider these two cables, they can only take up the load which is the tensile one. That means you can only pull the particular cable. There cannot be a compressive load. So ultimately these two cables, they are going to result in the upward forces because they are required to support the downward loads which are present on that particular beam, and these two tensions are likely to be different ones. Now let us see the problem statement. First of all, it is said that the tension in cable is to be found out when Q is given to us as 12 kilonewtons. Whereas in the second case it is said that find minimum value of Q for which the cable at D will become slack. Let us go back to figure. Now so far as these two forces, these two tensions are concerned, we can name them as T1 and T2, and both are in the vertical direction. Now to solve this particular problem, we will be having the equations of equilibrium like sigma fx equal to 0, and you will find that none of the force is in the horizontal direction. And so we proceed to the next equation, that is sigma fy equal to 0 and sigma moment equal to 0. Sigma fy equal to 0 will say that T1 plus T2 both are upward, minus 7.5, minus 10, minus Q, and in the first case Q is given to us as 12 kilonewtons equal to 0. So we will get one equation in T1 and T2. Now to get the second equation, it will be the moment at point B, or moment at point D, or moment at point C. See here, if we take moment at C, then moment of T1 as well as T2 will come into picture. We know that we are having only two unknowns, T1 and T2, and it will be better if we take moment at point B or point D, so that one of the tensions, one of the unknowns will result in moment equal to 0. All the distances are also given to us, forces are vertical, all the horizontal distances are known, 0.5, 0.75, 1.5 and 0.75. So we can easily take the moment with our assumption as clockwise moment as positive. So the solution will be based on simply two equations. Let us write them. First one, it is sigma fy equal to 0, which will give me 7.5, everything is in kilonewtons, which is minus because it is downward, plus T1 minus 10 plus T2 minus 12 is equal to 0, and we get T1 plus T2 to be equal to 19.5 kilonewtons. So we get one equation. The second equation